don't know, just a theory, something to chew on. There's no way we can tell anyway. Okay, there's a lot of stars out there. It's been estimated that everybody on Earth could own 2 trillion stars to yourself. That's a lot. Million, billion, trillion. The stars are really far away. Hubble telescope focused in on a dot. They thought they found a black spot in space about the size of a grain of sand held at arm's length. They looked at that spot for 10 days, and in that one spot there were so many stars they'd never seen before that they couldn't even count them. That's just one spot, the size of a grain of sand, new stars just discovered. There's a lot of stars. Stephen Hawking, who hates Christians and creationists, said, and won't debate me, by the way, Steve, I'll take on any time, he said, stars are so far away they appear to us to be just pinpoints of light. He said there's only one feature we can observe, that is the color of their light. So when you look at a star, you cannot see the size or shape of the star. All you see is what color it is. We assume that stars are like the sun and the sun is like stars, but that is purely an assumption. We don't know that. Some people say, oh yeah, we can tell by the elements that it's burning. It gives a color characteristic, the signature, you can tell the elements. Evolutionists never talk about this, but they are of course assuming that even the molecules evolved in other places just like they evolved on Earth. They're assuming the same 92 elements we have here will be the same found throughout the universe. They've never talked about that, but you have a real serious problem if you just assume that the same molecular arrangement evolved, because molecules would have to evolve too by your theory, which I think is a dumb idea. Okay. I taught high school trig for many years as one of the subjects I taught. If you want to find the distance to an object you can't possibly touch, like a star, you have to measure it with what's called parallax trigonometry. You have to know 2 sides and 1 angle, or 2 angles and 1 side, in order to calculate the distance to this unknown point, or to this unknown distance to this point, with simple sine, cosine, tangent. The problem is, Earth is only 8,000 miles in diameter, which is basically nothing compared to star distance. So to find the distance to a star, you have to get your observers further apart to make a triangle. That's a decent angle. Well, they look at the star in January, then they look at the star in June, and they get a much bigger base on their triangle. This is Earth's orbit around the sun. Well, it's 93 million miles to the sun, which is a long ways, but it takes light 8 minutes to get here from the sun. It's called 1 astronomical unit. That is, the distance from the sun to the Earth is an AU, an astronomical unit. So we are 8 light minutes from the sun, which means the diameter of our orbit is 16 light minutes. That would be the diameter of Earth's orbit around the sun. This diagram here shows a little yellow dot on the far left. That would represent Earth's orbit, 16 light minutes. A year has 525,000 minutes in it. That's a real skinny triangle if you did it to scale. It's like having 2 surveyors with telescopes 16 inches apart, looking at a dot 525,000 inches away, which is 8 1/3 miles. You set that up and draw it out on a piece of graph paper, you find you got a real skinny triangle. It works out to be an angle of 0.017 degrees at the apex. I think you can have a hard time measuring something like that. If you want to measure 100 light years, by the way, that was just to measure 1 light year. If you wanted to measure 100 light years, you'd have to move your dot 830 miles away, keeping your surveyors 16 inches apart. That's like having 2 guys on my roof here in Pensacola, Florida, looking at a dot in Chicago. If the guys are 16 inches apart and they're focusing on a dot in Chicago, that's a real skinny triangle, okay? Figuring 15 billion light years is clearly impossible. It just can't be done. And I don't think you can tell exactly where you were 6 months ago on opposite sides of Earth's orbit. That would be a stretch also. Okay, this textbook says parallax trigonometry can be used to measure distances less than 100 light years. I agree, much less. I think you'd have a hard time measuring 20 light years, but I'll give them 100, I'll give them 500 for the sake of the argument. The fact is you can't measure a billion. I'm not saying the stars aren't that far away, they probably are. I'm just pointing out we have no way of measuring it. We don't know how far away they are. If somebody tells you that star is 7.9 billion light years away, just say, how did you measure it? Was it a Stanley, a Lufkin, or a Craftsman? And who held the other end of that tape measure? Because I want to meet this guy. It just can't be done. So number 1, we cannot measure the distance to the stars. Number 2, we don't know what light is. Is it a wave? Is it a photon? Is it a particle? It behaves sometimes like waves, sometimes like energy. Nobody knows for sure what light is. We know what it does, and we use it all the time, obviously, but nobody's ever defined what light is very clearly. So the entire principle or concept behind a black hole is the idea that light can be attracted by gravity. Well, if light can be attracted by gravity, if black holes exist, which nobody's proven that either, but then the speed of light can't be a constant. At Harvard University in '99, they slowed light down to 38 miles an hour. The next year, they slowed it down to 1 mile an hour in the year 2000. The next year, they brought it to a dead stop. They took light and absolutely stopped it. This was done at Harvard, it was done at Smithsonian, and it was done at Cambridge. And by the way, that's how science works. An experiment should be demonstratable, repeatable, testable. Evolution is none of those. Nobody's ever demonstrated or tested or proven any of it. It's all in the mind. They think it happened. It's not science. Okay. At Princeton University in the year 2000, they speeded light up to 300 times the speed of light. Why would the speed of light be an unbreakable barrier? Barry Setterfield, Australian astronomer, did a lot of work on the speed of light question. He says the speed of light has decreased. He said in the last 300 years, at least 164 measurements of the speed of light have been published, 16 different ways it was measured. He said the speed of light has apparently decreased so rapidly that experimental error cannot explain it. Here's a chart showing that the speed of light has declined in the last 150 years. About 1960, the chart seems to level off, and everybody since about 1960 has gotten the same number. If you measure the speed of light today, you're probably going to get 186,282 point something miles per second. Okay. That could be because in the late 50s and early 60s, they began using the atomic clock to measure the speed of light. And the atomic clock uses the wavelength of a cesium-133 atom, which means you're using light to measure light. You have a rubber ruler. Of course, you're not going to see it if it's declining. It may be we're on the tail end of a logarithmic digression, or it simply may be we're using a rubber ruler by using this atomic clock to measure it. Here's a couple articles showing about how that the speed of light was apparently exceeded by a factor of as much as 100. Clear back in '88 and '95, there were articles published about this. The speed of light is not a constant. The Radiophysical Research Institute in Russia, the cosmologist there, said the speed of light was 10 billion times faster at time zero. Astrophysics and Space Science magazine, 1987. According to the Big Bang Theory, the speed of light had to be much faster initially. Here's an article from 2001, Science News, saying about the speed of light may have changed over history, study says. Imperial College in London, the man wrote an article and said a shocking possibility is that the speed of light might change in time during the life of the universe. At the Rutgers News Service put out an article from Sydney about a team from Australia that said the speed of light may not be a constant in August of 2002. It says the speed of light can change. The speed limit of the cosmos is being questioned. September 2002. So, there's a book out called Faster Than the Speed of Light, and I'm sure this fellow who wrote this book will be persecuted for daring to suggest such heresy as this. Discover magazine ran an article about this. Was Einstein wrong about the speed of light? A recent article saying Einstein was wrong. The speed of light is not a constant. So, I don't think we can prove what light is, and I don't think we can prove light's always traveled the same speed. Number 3. The creation was finished when God made it. It's interesting, Jesus made wine out of grapes that never existed. Turned water straight to wine. Where's the grape stage? He can make a full-grown man out of the dirt and then make a woman out of his rib and make animals out of the dirt. He can make the earth out of nothing. Jesus made enough to feed 5,000 people out of a little boy's sack lunch. We're always trying to limit God. I get real worried about folks that try to put human limitations on God. God didn't make 2 babies and put them in the Garden of Eden and hand them a package of seeds and say, here, plant these quick, you're going to need supper. He made a full-grown man and a full-grown woman in a full-grown garden. That's the only way it's going to work. Number 4 thing to consider. A light year is a distance. It's not a time. It's a distance. It's the distance light can travel in a year at today's speed. A light year could be done in 1 second if you speeded the light up. It's simply a distance. It's like so many gazillion miles. I think 6 trillion miles is a light year. Okay, number 5. Since the speed of light is not proven to be consistent, why would star distance have anything to do with age of the universe? Some people say, oh, wait a minute now. I know we can't measure the distance with triangulation, parallax trigonometry. What about measuring with Cepheid variables or redshift? Well, that's the other way they try to do it, and also loaded with flaws in the theory there. The redshift is the idea that when light goes from a star, the red is shifted over. They look at the light through a spectroscope, and you'll see black lines on there, and the black lines are shifted toward the red end of the spectrum. You get the normal spectrum, red, orange, yellow, green, blue, indigo, violet, but the black lines are shifted red. And they'll say, wow, this is proof the star is receding. It's moving away from us. That could be, I don't know. But there might be other ways to answer this. This is called the Doppler effect. If a train is coming toward you, it squeezes the sound waves in as the train makes noise, and you hear it drops pitch as it goes past you. It's called the Doppler effect. If you're going past the sound source or the sound source is going past you, either way it works the same. Sound is called compressed coming in and refracted or stretched going out. Well, they thought possibly if the star is coming in, it would squeeze the light waves, whatever light waves are, and make a blue shift. If the star is leaving, it would make a red shift. And so when the red shift was discovered years ago, they looked around the heavens and found most of the stars are giving a red shift. And they said, wow, this proves they're leaving. No, it doesn't, but that was the assumption. And then they said, if all the stars are moving away, that proves there was a Big Bang. That was the